Hi girls, so another video. It's going to be on 3 little things that all should be revision from last year in coordinate geometry. So the first one is midpoint, and I've just drawn a really beautiful number plane there. Let's label my axes while I'm at it with 2 points, and I need to find the midpoint. And I'm sure you've been told this 1,000 times before, but basically the midpoint is the point in the middle, right? It's the point that divides the interval in half, and I've got a formula over here, and so I can use that formula quite easily. So I'll just take the average of the x's and the average of the y's. Close the brackets, maybe just. And so what's that? 1 on 2, 5 on 2. And that's the midpoint. And that's that. Right? Nothing really too much to say about it, especially because I'm sure you were told a lot about it last year. But midpoint, it's in the middle, as you expect. So you find the averages. A slightly different example now. So we've given the midpoint this time of 2 points, and we need to find one of the points. So this means that the point 3, 4 is, so it's the average of x and 2 and the average of y and 8. And then so we get 2 sets of equations. First one's in yellow. So the yellow one's giving me x plus 2 on 2 is 3. X plus 2 is 6, so x is just 4, and then the leftovers, I think I meant to say, so y plus 8 on 2 is 4, so y equals 2 lots of 4 minus 8, which is 0. Done. Okay. Quiz question now, I hope anyway. Next one is the distance formula, and just like with gradient that we did yesterday, or day before, depending on when you're watching this, I would like you to always draw a triangle, and to remember that the distance formula, that wasn't very good, is just Pythagoras' theorem. Right, we're going to construct a right angle triangle there, and the distance is just, well, let's do the distance squared. So it's the sum of the squares of the 2 sides. So firstly this one here, so that's how far it's gone up. So that'd be 4 minus 1. And the distance here is how far it's gone across. So that would be 7 minus 1. So in this instance the distance squared is, that's 9, and that's 64. So distance squared is 73, so the distance is the positive square root of 73. There's nothing else you can really say about that. I'll write down the formula. It's on the reference sheet, there's no need to memorize it. But it's just the distance between the x's and the distance between the y's squared. And I'll ask you to think about what the mistake that you will probably make at some point, but that you should absolutely never make is, and we've spoken about this particular mistake already quite a few times. The last thing is the perpendicular distance, and I'm just going to write the formula down for this one. Again, you were shown this last year, so it's the, let me start again. So the perpendicular distance from a point xy to a line, and this time it's important that the line is in general form. General form means equals 0, and it would normally mean positive coefficient of x and integers if possible. It doesn't actually matter in this instance whether it's positive coefficient of x, but you might as well just do it properly. And the perpendicular distance is given by this formula here, which is the absolute value of, you basically, let's call this x1 and y1 just so we don't get confused. You sub the point into the line, and then you divide by the sum of the squares of the square root of the sum of the squares of the coefficients. But again, if you're a big fan of memorizing, go for it, but it's on the reference sheet. Okay, so there's no reason to memorize this whatsoever. Okay, but again, as with everything we do pretty much, if you don't memorize it. If you haven't got it memorized, it probably means you haven't done enough practice. So let's just do a couple of examples of this. So firstly, let's find the perpendicular distance, which I'll just use perpdist. From the origin to the line y equals 3x minus 7. So let's just say that's a question. So the first thing I would do is I would rearrange the line to be 3x minus y minus 7 is 0. And remember that the origin is the point 0, 0. So then my distance is the absolute value of 3 lots of 0 minus 7 all over the square root of 3 squared plus 1 squared. You can write plus minus 1 squared, but I mean it's going to be positive no matter what I do, so it doesn't really matter. And then this is 7 divided by the square root of 10, which I could rewrite as 7 root 10 over 10 as well if I wanted. But that's the answer to that one. Let's do one more example before we call it a day. So let's find distance from 6, 4 to this line here. And let's write this so it's even remotely legible. And it's just worth pointing out that often these things come about because we are asked to find the area of triangles in the plane. And so we find the base length using this. We find the base length, and then we find the perpendicular height using this. And we'll hopefully do a bunch of examples like that in class. So distance, sub it in, so I get 6 plus 4 minus 1. I forgot to rearrange, but hopefully that's pretty obvious. Divided by the square root of 6 squared plus 4 squared. 6 squared plus 4 squared, what's that? No, not very nice. So I get 9 divided by the square root of 36 plus 16, 52, I think. Sounds about right. And then you could do your normal surdy stuff there as well. Okay, that'll do us for today. See you Friday.